Thanks for coming, guys. I know it's late in the day, and we'll try and entertain you a little bit and give you much information about what's going on at Microsoft when it comes to Internet of Things. There's a bit of background about myself that I'm going to give you in a couple of minutes, and then we'll dive into what Microsoft has to offer when it comes to IoT. I'm not going to tell you, here is Microsoft's strategy. I'm not going to show you the latest Microsoft wearable device. This is not it. This is just a Nike wristband. And I will not confirm or deny any rumors about what's going on the news these days. But what I want to do today is talk to you about the perspective Microsoft has on IoT in general, and what are the various teams working on IoT solutions, whether in the cloud or whether on devices or in between the two of them, and show you some demos. I want to show you some code. I have some hardware here running Microsoft stuff, non-Microsoft stuff, connecting to Azure Cloud, and so forth. I'm part of a team called Microsoft Open Technology, and MS OpenTech, as we like to call it, is a subsidiary of Microsoft dedicating to bridge Microsoft and non-Microsoft world. And you'll see how much relevant that is for IoT. I don't know how much you're familiar with IoT in general, but you can imagine that connecting a device to a gateway with a specific protocol, gateway itself connected to an infrastructure that is connected to the cloud, all of these things need to interoperate. They need to talk to each other. We need to work with a common set of protocol, common set of languages, common set of things to work on. Our team is really meant to build these bridges. So we contribute to existing open source projects. We work with various open standard bodies, W3C, IETF, OASIS. We make things that are open source work on Microsoft platforms. You see a bunch of names here about database technologies or Node.js on Azure and so forth. We have something called VM Depot, which is a repository of Linux virtual machines for Azure. Everyone knows what Azure is, right? That's Microsoft Cloud. That's Microsoft AWS. Let's put it like that. So Azure is hosting Linux VMs, and we have a repository of community-driven, shareable VMs, about like 350 of them now, on VM Depot website. So you can check it out and find many different Linux distros with various configuration and use them. On the web side of things, you can see things like jQuery, Sencha, Apache Cordova, AngularJS. I can talk more about these ones after if you're interested, but basically, MS OpenTech is the team putting his dirty hands into these open source projects, making them work on our platforms in an open way, always willing to help you guys get your stuff running on our platforms. Last but not least, we are a structure that allows Microsoft Product Group open sourcing their stuff. Win.js, which is a JavaScript library for graphics, and which you can hear about on the Microsoft booth here, is open source through Microsoft OpenTech. The .NET Mic framework, we'll talk about that, is also open source through Microsoft OpenTech. That's what we're doing. Let's talk about IoT now. The context, well, the 3-4 next slides are certainly things that are obvious to you guys. I still want to state them and talk a little bit about them. That might not have been obvious to you, but Henry IV of France said in the 17th century that he wanted a chicken in every pot. And that's about the perspective of things. Bill Gates, different times, different things, but said he wanted a computer on every desk and in every home. Now we have a very smart guy leading the IoT division, program managing at Microsoft, called Steve Teixeira. And actually, he is aiming at putting a computer in every pot and every chicken. That's his words. And so the idea is really to say, we really want to have intelligence on devices. We really want to have intelligence on the back end and making sure that it's accessible by everything and by everyone. To make a great IoT solutions, once again, these 1 or 2 slides, and I'm going fast through them because I want to get to the demo. To get a great IoT solution today, you need to have smart devices, intelligent connected devices. And you'll see why. You definitely need to have a level of intelligence when a robot arm actually is acting on something, you don't want it to be solely controlled by something that is remotely accessible, that connectivity to that thing that controls it could be broken or whatnot. You need to have that device smart enough to know what to do in a situation where it's not getting information or commands. Okay? So I have a little robot here, and at the end of the session, we'll make the experiment of having you controlling it through a web page and through a gateway, Zigbee, to the device. That device should not fall off the table. We'll see. The second aspect of a good IoT solution is the ability to act on changes in the environment. Acting fast, acting in real time if possible, whether locally, whether when you're distant. It could be about getting the right information in the right time, the right alert, the right information, the right data, and sending the right person to fix it, sending the right command back to the device. You need to make sure the data that is transitioned from the device to a backend stay integral. You need to make sure that the integrity of the data is not, I'm not even talking about security. I'm talking about making sure that the alert is really an alert. You need to make sure that data means something. Acting on these changes actually is something you need to have that data integrity in between. The other thing is you need to tap into the data to do something out of it, to eventually do preventive maintenance, to optimize your costs, to optimize your productivity, and so on. So you need to be able to do something out of the huge amount of data that is going to come from these devices. Imagine a motor that is actually sending its actual speed every, 10 milliseconds or something to a backend. Well, you multiply by the number of engine or motors you have on the factory floor, you can imagine the huge amount of petabytes of data that are coming out of that. And you can't do much out of it locally. And if you don't have a well-structured data in your backend to understand what that data is and the right tools to do something out of it, well, it's pretty useless. So you need to have a very strong backend to scale and manage all of that data. Sorry. So the data definitely is what drives the control and the insights. So you need that data actually to really do something out of it. The devices themselves, I was saying, need to be smart, and you have various types of data that can be produced by these devices. You need to have some sort of intelligent management in between. You're going to add and remove devices. You're going to eventually filter the data. You're going to have to do mobile devices monitoring of what's going on. So you have that level of intelligent management in between. And then you have the backend. And here you see some names of products on the backend side of things, Office 365, Excel, Agent Insight, and so forth. We'll talk about these services. Back to the title of the session, Microsoft has tools, has platforms at every level of that stack. Doesn't mean you need to use only Microsoft all across. It's very important. You have solutions, and we'll talk about some of them here and there, whether on local infrastructure, in the cloud, or in between, what I would call the place where you have the intelligent management. Could be local, could be distant, could be server on a factory floor, things like that. Microsoft is in there, for sure. First one is Azure, with huge physical global infrastructure across the planet, and bunch of services. A lot of services. I'm not going to go through all of them. That's overwhelming, and they're not all listed here. But you have various types of services, as you would expect from any sort of big cloud. Compute ones, where you can generate, create your own websites, virtual machines, build your own cloud services, with cloud workers. You have data services, the basic ones, databases. We mentioned in one of the first slides, you have also NoSQL databases that are supported thanks to the work MS OpenTech is doing. So you can choose the structure of data you want, or you prefer. You have networks, also services, where you can actually do virtual networking on the cloud. That's pretty useful for a certain situation. And then you have the app services. Out of the sea of services, and once again, we can talk more about some of them later on, I want to highlight a couple of them. So Service Bus is one of them. It's over here. And what Service Bus is, it's a big mailbox for you to send messages and receive them. So you create queues, you create what we call topics, you create what we call subscribers, and devices, applications, services can send data to these queues, and devices, services, or backends can actually read from these queues. And you'll see that we have some service called Event Hub at the far end on right here, which is a very new service on the Azure offer, still in beta for now, which is actually a Service Bus 2.0, offers the capability to ingest a huge amount of events. We're talking millions per second into the cloud. So ingest that data, making sure that this data is integer, that it is actually tagged with timestamps and so forth, that it can use it down there in services and applications. Another very interesting one is ISS, Intelligent Systems Services, and we'll see a demo of a solution that the London Underground is working on with Microsoft to implement on top of ISS, which is very much of a complete solution for Internet of Things solutions on the cloud. Another one is machine learning. And we'll talk about that a little. Machine learning, obviously you have tons of data. You want to apply analytics, statistics on that data to determine patterns and eventually take actions on things you see are coming up. Azure allows you to develop using all these languages up there. So you don't have to use .NET if you don't like or are not familiar with that. You can use all these languages. You have SDKs for all these services that come for the various languages that are available as programming language on Azure. That's what Azure looks like from super high. And what I want to show you as a first demo, actually it's interesting. I'm missing this slide here. This slide here is about ISS itself. Sorry for that. So the Intelligent System Services, I want to dig a bit into that one here. ISS is a set of services that will be released real soon. Not today. I can't announce that today. It's private preview right now. And the idea is to gather various services. There's some machine learning, there's some stream insights, there's HD insight for big data. And we provide that as a service with one price for it. And you have a bunch of tools you can attach to the services. One of them is the ability to work on various hardware platforms. Client library that will be open source that allow you to attach a Raspberry Pi, a ARM-based device running something else, Linux, whatnot, Windows machine eventually to that cloud. You will also benefit from dashboarding tools out of the box. So you have basic dashboards to look into the data, monitor what's going on, put alerts on. You also have the big data visualization tools. If not Excel, you can actually build your own ones and really have a visualization that allows you to do something out of that big data. It actually works on top of HD Insights, which is one of the big Azure services stack. You can build your own custom line of business applications, and I'll show you one, which is London Underground one in a second, based on APIs that are made available, HTTP REST APIs that they can use, and leveraging the SDKs that are released to go along with that. The integration into the enterprise is also key. You have a fleet of devices that your employees are using as an enterprise that you might want to be able to deploy ISS clients to. You also eventually have a way of managing your devices in the field, whether they are ATMs, robots, cash registers, or whatnot. You want to be able to deploy applications, updates. You want to be able to do maintenance on them and so forth. And you actually have an integration to the Azure Intelligent Systems Services of these management systems and services. Think of it as a way to monitor what's going on, do data analytics, control back. It's not one way. It's not just about ingesting the data and doing something out of it. It's also about controlling back. And all of that in a very controlled manner and as a one service from Microsoft. That's what I call the black box service from Azure for IoT. Otherwise, you have the do-it-yourself with the list of services I showed you before that allows you to build your own solution. Okay, a bit overwhelming, definitely. I want to dive into the devices part of it. So Azure is interesting, definitely. I'll talk about the ISS one in a second, but obviously I want to jump into what the devices can do here. So here's an example of an ISS client app. So Microsoft is working with the London Underground. This is something that has been going on for some time. And the idea is the ask from the London Underground is to have a tool that allows them to manage the full infrastructure, personal, all the assets, deal with alerts, and obviously, as you can imagine, enhance the way things are dealt with. That application here shows what could be the final application. It's not real data. It's data that is actually faked. But the idea is really to demonstrate what kind of functionality, what kind of features you can get from ISS. In that case here, I have an application that shows me the status of every single lines in London that I can actually have alerts displaying here. I can have basic information about the lines themselves at a first glance here. I can also have a graphical view of what's going on, and I can inject information into charts like that. For example, here I know that I have an employee, Eva Cortez, in that station, and I could eventually interact with that person from here, giving a phone call, IMing, and so on. It's a 15-minute session. Sorry. So. Yeah, so we're good. we're here for 15 minutes. We're good. So here you have a real way of interacting with that data in a graphical way. And you can also in that application integrate data from the outside, from outside services like weather, like news, and so on. So that's definitely a view that for your manager in that case is very useful. Let me dive into, for example, one of the lines and see what the status is. I'm able to get information from sensors that are in that station. The temperature is definitely something very important. You might not realize how important the temperature in a subway station is. The noise also, noise level, not just for comfort, it's also about vibrations on the various engines, machines, and so on. So that's something that, at first glance, this guy can see. He can then make a decision based on that. On the graphics here, we can go even further. I can see that I have some webcams. I can check if they're working. There's one red up there, so it's certainly not working well. And then I can see that elevator here is also in red, so that means something is going wrong. I can, as the manager, look at that and say, okay, what's going on with that elevator here, escalator, sorry. I can see that there's some vibrations that are above a threshold. So that's some of the alerts you can get to prevent something to break. You have these little vibration sensors on every wheel in these escalators, and you're able to define when it's going to break. In that case, it tells me that if it's not resolved in 72 hours, then this asset will be disabled for security reasons. You can have something that actually the threshold in this particular case cannot go beyond 4 millimeters. This is a setting that has been set as in the ISS services, so that the alert is triggered, and I'm able to configure all of that on ISS. And here I'm able to say, okay, I need to do something about that. So I will create my ticket. And that ticket actually will be about defining a date. Obviously, I want it to be done immediately. I'm going to indicate to the guy who is certainly the closest there what needs to be done based on the information I'm getting from the alert and what's broken and what's needed for repair that one. I have a default designation of that guy here to work on that issue. So that's very much the use you can do of the data in the back end, present that as a front-end application, all configured in one service, which is called ISS. You'll get a chance to have a public preview of ISS real soon. I want to show you rapidly what it looks like when you are the guy actually doing the maintenance. There's a different type of UI adapted because of that login. And the guy is able to say, okay, I have an alert here. I have that wheel on that escalator that's broken. I know I have to do that, that, and that. Obviously, that's going to optimize his workflow, and that's going to optimize the overall process in my subway here. So that's a very high-level demo of what an ISS solution can and will be. Oh, let's go back in here. So when it comes to doing an IoT solution, I was mentioning that ISS is that one big black box thingy. Now you can also think about doing that solution yourself. Here are a few services that you can think about as key for your IoT solution that are on Azure today. You have HD Insight, which is Hadoop, 100% compatible. So basically, if you're an Hadoop developer for big data, you can just like get onto HD Insight and build your big data compatible application up there. You can use machine learning. So machine learning is what powers today Xbox, Bing. So I mean, like it's robust and it's been tested intensively. It has first-class support for the open source language R. I didn't know what it was either. I don't know if someone knows what language R is about. No? Okay, so language R is a different name for language S. That's what I found on their website. It's a statistical and graphics language. You'll basically build models for your data in a graphical way to then inject rules and have information from data. Right, so that's a very very advanced and used language in the mathematical and in the financial worlds today to determine trends, patterns based on the huge amount of numbers. The last one is event hubs. So event hubs is that big huge mailbox that allows you to get millions of messages to the cloud in seconds. So the idea definitely is not to lose any data, to be able to bufferize that, and to then have various tasks in the cloud that will unpile that data and do something out of it. Make sense? So Event Hub is a new service dedicated for IoT that allows you to really send all that data up there. I want to show you, how that works real quick. On the back end, if you've never played around with Azure, that's the main Azure portal today. We have a rebranding happening, but that's what you're going to see if you go there today. And you basically bring up your services in that web page. You want a new website, you want a new worker role, everything works in that page. In that particular case, I went into Service Hub and created an event hub. Let me go back once. And that event hub basically is a big queue that will allow me to send data in a secure way. The only information you need really for developing with Event Hub is that access connection information. Your application will use various types of protocols to send data, whether it's HTTP REST. Today we support AMQP. In the future you will support MQTT, CoAP, and other machine-to-machine type of protocols for devices to send data and receive data from Event Hub. That really allows you to connect a lot of devices up there. Once I have selected, that service bus, I'm able then to, work on devices and have them send data. I have a Raspberry Pi here that is running Node and a small Node application. Let me try and connect to this guy here. This is where I was saying that the connectivity will be interesting to see. If I can connect to my Raspberry, yes. Oh. Okay, so if you're familiar with Raspberry Pi, that's the usual SSH connection. I'm going to go to one of the folders here, and you will see that I have a Node installed here. I have a JavaScript file. What I want to do is show you what's in that JavaScript file. All right. And that file actually is simply about using HTTP REST to send a message to Event Hub if he wants to come. Okay, guys. Okay. So if you're a JavaScript developer, this will look familiar. Okay. Give me a mouse. Okay. On exactly what's going on. And it doesn't want to come back. I love it. So don't install Windows 10 on a demo machine just before the demo. It's a bad idea. Okay, so here is the JavaScript file, very short. And what it does is basically create an access key token. That's a very short function to do that, using the various information I got from my Event Hub key and key name. And from there, I'm just going to do a usual HTTP post, HTTPS post, with that information with a payload. The payload actually is just, in that particular case, some temperature, fake temperature information. Temperature equals 72, and that's all you have to do. Right, so from a device communicating with Event Hub is as simple as just pushing that. I'm going to launch a listener on this machine here. Let me go back here. Here. And this listener, he is using AMQP this time to see what's going on the Event Hub. Let me go and pick it up. Where's the guy? Oh, there you go. So I was mentioning that Event Hub is really that hub in between your device and services. In that particular case, I'm using some code that actually is C# code using AMQP and getting the data from the Event Hub and displaying it. So it's really about using, this time, the SDK that comes along with Event Hub for C#, creating various tasks that will listen to that Event Hub message box and do something out of it. So you have various devices that can post to one Event Hub queue, and then you can build various tasks that are listening to one queue, but still have coherence when it comes to the data. The data is stamped. You know which workers are listening to which partitions of your message queue, and you're able to do something smart about that data. Here we're just ingesting the data. I'm not showing what you could do with that in terms of the backend. So that receiver here, I'm just going to start it. And it will run here on my local machine. Oops, where is it? And just listen to that Event Hub that's been created. And on the Pi, I can just start this send event hub.js JavaScript code, and it's going to send data to that Event Hub, and hopefully it's going to be read on the other hand, which actually is my C# application. I will share that code with you guys as samples, but there's a lot of documentation on Azure about Event Hub that you can read through and get some information on. You have a question?
Is the device, you log into the device time, or you just saying the Event Hub login?
So that Event Hub has been created in a way that is like, it's secure. No one that doesn't have the access key and the device access key, the access key name, can access to it. So the idea is to make sure that only someone who has that you know about is sending data to your Event Hub queue, right? And same thing to read the data. You want to make sure that not everyone can read. Beyond that, you can actually create various keys with various rights. And you have three types of rights for the Event Hubs. You have the manage, this full read, write, configure. Then you have the send, and you have the read, right? So basically you can say a device can only send to an Event Hub. An application or service can only read from Event Hub, or can do both. Or a service or an application can configure that hub, meaning destroying it, creating a new one, changing its structure, changing the number of partitions, and so on. So that's something that you can change not only in the management portal, but also from an application. Make sense? Okay, so that's a very fast, I know, work through what's going on the Azure side of things. The other part, which is very important and interesting, is what's going on the devices side of things, right? So Azure lots of services, various services for you to do big data analytics and so on. On the devices side of things, you have the possibility to run Windows or Microsoft technologies on small devices. Obviously, you might have seen news about Windows 10. The fact that it's the same core across devices from Intel Galileo, which is a maker board I'm going to show you in a second, all the way up to Xbox, not forgetting the perceptive pixel big screens up there. All of these machines, whether they are phones, tablets, desktop servers, or consoles, they are running the same core. They're running potentially the same software. There is a family of products called Windows Embedded that actually are using the same core as Windows for consumer devices, I would say. And you have the possibility to adapt Windows to any sort of devices. Today, 80% of the ATMs run Windows. Today, 90% of the cash registers run Windows. You don't know because it doesn't look like Windows and because it's not managed like regular Windows. You have various classes of devices that these customized version of Windows can address. The standard ones, and we have a product called Windows Embedded Industry, which is basically Windows with a certain set of features specialized for embedded. Fast boot, lock down the UI, boot into an application versus the shell, and things like that. You have the mobile type of devices, and we have something called Windows Embedded Handheld, which happens to be based on Windows Phone. So imagine a locked-down Windows Phone type of device, which actually runs only one app or a set of apps of yours. And you're able to have that as your device in a factory floor or in a warehouse where people will scan objects and connect to a backend and so forth. You can manage these devices using usual device management tools, usual PC management tools, and so forth. For small devices, there's something called Windows Embedded Compact. Compact used to be called Windows CE. It's a hard real-time OS. When I say hard real-time, I mean able to be predictive and respond in the amount of times that are controlled. So that's used in robotics, industrial automations, and so on. And the last one down the pile here is called .NET Mic Framework. It's an open source project now, and it's about running .NET directly on the silicon. I'm going to show you that in a second. You're able to build a .NET app very simply, connecting various sensors onto, in that particular case, a connection board called Gadgeteer, and do something out of it. So that's really about pure .NET on small devices. Last but not least, there's that program called the Windows Developer Program for IoT, which is about Windows running on small devices, big Windows, tuned down for small devices. Think about a Raspberry Pi class of device. So in that particular case, the Intel Galileo board. Think about that class of device running Windows with no UI, stripped down to something that's still big, but way less than big Windows. We're talking about 600 megs here on my micro SD card, booting from the SD card. And potentially in that case, powering an Arduino shield to get information from sensors or controlling whatever you want to control. The advantages of running Windows is obviously familiar development environment if you're coming from the Windows development world. The device manageability, because you get the same services level you can get on a big Windows. And it's free. So you don't have to pay royalties for using Windows. And you can develop using Visual Studio Express, which is free also. So as a maker or as an industrial, you should definitely start looking into that program if you're interested in running Windows on small devices. That is an open source project also, in the sense that to talk to Arduino shields, in that particular case, the Intel Galileo needs to talk wiring. Wiring is that programming language for Arduino shields. And we developed an implementation of wiring for Windows that we're going to use in an application in a minute in order to connect to these shields, send data, receive data, and so forth. That is open sourced. through MS OpenTech once again, so you guys can contribute back. We can work together on that project and make sure that a Windows-based machine can run on these tiny devices, and you can take advantage of this hardware that is off the shelves today. Okay, so how about we start coding some of that? I know you guys have been patient with me so far. I'm going to try and show you a couple of things you can do with the .NET framework and the Intel on Galileo. Let me just kill the things here. Okay. And I'm going to start with Intel on Galileo. Okay. Okay. And this one. Okay. As usual for development for Microsoft platforms, Visual Studio is the tool you want to be in. And when you install the program for IoT on Windows, there's one thing you're going to get in the C++ type of project is something called Windows for IoT, and there's a Galileo wiring app. That's going to give you the basic skeleton to run an application on the Intel Galileo running the free Windows image. So I will start that project, and I will use a Galileo Gen 1 because the Gen 2 support is not super dry, and some of the demos were not working with that one. But we have an image for the Gen 2 Galileo that just went out recently, and I will certainly have these demo and code available for Gen 2 in a few days or weeks. That skeleton here is, if you are an Arduino developer, very familiar. You have that notion of an Arduino sketch, and there's no difference. It's C++ code. You'll work around with pins. Here you can see that I set a new int, which is called LED. It's going to be pin number 13 for a digital I/O. And what I'm going to do is digital write, digital read, if it's an input, and just control it like that. Fairly easy, fairly simple. In our case, I don't do the blinking LED because you know about it. It works like every other. But we have a wiring weather shield here. And what I want to do is actually get the code that comes from GitHub for these libraries, drop it in Visual Studio, compile, and run it. We'll see what happens. The first thing to do is get the library code. And for the sake of time, I downloaded the two libraries from GitHub sites. I've not altered anything. I'm just planning to bring these CPP and .h files. So this one is about the humidity sensor. What I want to do is go in this folder here on my project, paste the files, do the same thing for the other sensor, which is the pressure sensor. Let me go back. And library, and pressure, and here I have CPP and .h. So these are exactly the same library source code files you would drop into your Arduino project to use one of these Arduino shields. And once here, what I need to do is add them to my project. So these two guys here will go to my source files, and the two headers, obviously, to my headers folder. There you go. Once here, actually what I wanted to do is eventually show you that website which has the samples, and I will show you the piece of code I'm actually getting from these samples. The Windows on devices is the place you want to go. Make, and here you have the samples. And this is a GitHub site. And here you have a bunch of samples to use on the Intel Galileo, both Gen 1 and Gen 2. And here you have the piece of code for the weather shield. That piece of code has been just taken from the samples on GitHub for pressure and humidity sensors. So it's nothing special. And once again, if you're an Arduino developer, you will be pretty familiar with what's going on here. Let me get the headers first. Oops. And drop them up there. I obviously need to create my two objects. Okay. I'm going to get, sorry for that, I'm going to get a mouse. dying. Yes. It's going to be way better. Okay, these two guys here. And I need to initialize them. So as we are in the US, we'll use that little function for temperature in Fahrenheit. It's freaked out some guy internally in the team that we're using Celsius. And I told him, no, you're good. Don't worry. And I say, no, no, no. We put a function for Fahrenheit. Okay, so in my setup function, let me just discard that pin code. What's going on is that I do the wire begin, which actually initializes the wiring stacks and allows me to, in that case, initialize the I2C connectivity. And then what I do is begin the transmission. That first transmission here is to basically tell the shield that I'm going to listen to it. I'm going to be a reader on it. And then I will start the reading and of the both humidity and pressure sensors. So that's basically what's going on in terms of initializing the shields. And here I'm just going to read the data during the loop. So these two functions are once again familiar if you're an Arduino developer. Setup loop is something that actually is nothing different to what you can find there. And here I just call the object myPressure and its function readPressure, get the information from the shield. And that's I2C communication that happens in the back. I don't really see it. I don't need to because that's happening in that wiring stack implementation. The last thing I need to do, that device is running. It's on the network, and actually I should be able to see it on my network here. We have a little tool called Galileo Watcher. I can see its name, I can see its IP address, and so I'm going to set up my debug environment in my project in order to connect to it. And here I have the default is that, and it was what? 115, right? Let's go for that. And Visual Studio here is giving me the ability to do remote debugging. So the code will be deployed to the target from Visual Studio, executed down there, and I'm going to receive all the debug messages back in Visual Studio so I can do my debugging in Visual Studio, which is not running on the board, right? So I can have very beefy machine for development, very little tiny machine running the minimal that I need for my application, and then run this app from here. So I'm starting the debugging, it's building, it's deploying, establishing the debug connection, and then it should hit my breakpoint here while running. I've not created code. I've just been using, yeah, it's C++ code. You have warnings. Fine with that. So basically, I've not been modifying the sample code from Arduino. That's really what the demo is about here. I'm able to get that information, to use that code, sorry, and in that particular case, get the information from the wiring device. It says no pressure. It says we are super high. And it says it's 97 degrees here on the device. So it's pretty warm. It's an Intel board after all. So we've seen like how easy it is if you're an Arduino developer, if you're a maker and want to give a try to that, you don't have to learn a new language, you don't have to learn C#, you don't have to learn anything else. Just use your regular C++ code, dump it in Windows, and run. That gives you a Visual Studio as a development tool that uses an open source stack in between to communicate with the Arduino Shield. So you're set really for good development for IoT here. Another thing I want to show you is .NET Mic Framework. Are you familiar with .NET development? Some of you. How about doing, and that's fine. .NET is cool. I like C++. I've done a lot of embedded development. But I like C# too, especially when it's that easy. If you have done embedded development, you know how hard it is like to get to hardware. Having as fewer steps to get to hardware as possible is really good news. So .NET Mic Framework offers not only a runtime for .NET that runs on tiny silicon, but it also offers tools that allows you to, as a hardware manufacturer's instrument Visual Studio, to make the experience of the developer better. what I'm going to do here is build a new project using Gadgeteer. So Gadgeteer is a Microsoft research project that consists in defining a connectivity model between a sensor or a small tiny device with .NET Micro Framework. I have a board here, developed by GHI, and that board actually has a connector on one side that allows me to bring a lot of little sensors on the board, and it's kind of like my 5 years old actually likes playing with that and building his own stuff. I help him on the code side of things, but when it comes to plugin and so on, it's like Legos. It's pretty funny. In my case, I'm gonna use a button. So I have a small, you can come and check out the hardware after the session. I'm gonna add a button here. The button, let me check, is connected. That's a big mess here. To this guy here. So the button here is connected to that plug, and you see you have some that you can connect to, some you can't, and that's the magic of the Gadgeteer. But all in all, you are able to connect a bunch of things in there. I have a display, a small LCD display. This one actually you have 3 or 4 things to connect, and you have the RGB plus the power and the control lines. It's going to go super fast. Okay, how about we add a camera? How about we're going to take pictures and display them on the screen? And this little camera boy here, we're going to put in there. So we have a button, we have a camera, we have a display. Fairly easy and standard. And actually, I did something stupid. I did a VB program. Let me do that again. Okay. Gadgeteer and C#. That's better. So I'm going to do the same. Sorry for that. I'm not in a good shape today. Okay, back to what we're saying. Display. And I've not measured how fast I can do that. There's a tool actually that allows you to say connect all, and it will automatically find the best plugs for the devices. So I'm not doing that because then I have to change the connection on the device itself, which you don't want me to do. It's going to take even more time. So my button is here, and I said 11, and the camera. Down here. There we go. Okay, good. Let's get to my program. Here I have a bunch of C# code that has been generated for me that I don't need to care about. What I need to care about is things like that. I will actually add an event handler on my button. When I'm pressing it, I want something to happen. So it's, yes? Yep, I can do that, sorry. Yes, that better? Okay, let me zoom into it. Okay. Yes, much better. Okay, button pressed. And as usual, you are helped when you're doing work with Visual Studio and IntelliSense. Actually, I want a new event handler. There you go. And it's called button pressed. Another thing I want is the camera. So where's my camera? Camera. I want to say when there's a picture that's been captured, I want to add a new event handler. Same thing. I'm going to describe it. Here, once again, I want a new statement. And this is a new event handler for the camera. And that's pretty much it. I'm set for events on the camera and the button. When I hit the button, obviously what I want is the camera to take a picture. Oops. And it's called Take Picture. Simple as that. And when the picture is captured, I want it to display. So I will go to my display, and there's something called Simple Graphics, Display Image. I can display a bunch of things, but image is definitely what I need here. and just drop that image that is coming back from the event picture, and I want to put it, here at the origin of my display, and that's it. So here I just created my camera with .NET Mic Framework, and we'll try and make it work. So I have a Mic Framework device here. It has the various sensors. It has a display. It has the camera. It has a bunch of other sensors. Eventually we can talk about if you have questions later on. And I should be able to just connect it and deploy the application, which is .NET Mic Framework, onto the device, run it, press the button, capture the image, display on the screen. Obviously, oops. Interesting. Oh, let me see. Maybe I should target this version of .NET Mic Framework. That'd be better. Okay, build. So you have the latest version of .NET Mic Framework is 4.3, and that's the tiny CLR I'm running on that Gadgeteer kit is 4.3. So obviously I need to have the same version on both. So it actually is doing the deployment. That's good news. And it's running. I could have put some breakpoints on my code here, and actually I'm able to do that. And for example, when I will hit the button, it's going to hit that breakpoint. It should. Or it doesn't. Yeah. Look up. Yeah. Is it running? It should be running. Or it should not. Okay. I think I'm not lucky today. Shh. I think that's really not my day. Sorry for that, guys. But you have the idea. That thing actually... Sorry. Actually, he was telling me that I was trying to deploy a version of my application that was built for the CLR 4.2, and actually I had a 4.3 on the target itself. And so, mismatch, and I guess this is because I should have started with 4.3, and the reason why it's not working is weird. I don't know, but I need to look into that. But the idea is really to have very simple code to access hardware using C# code, and actually do something out of a kit like that. You have various hardware today that support .NET Mic Framework. The Gadgeteer is one of them. You have Arduino, which is another one that has an Arduino-compatible connectivity that you can actually use Arduino shields. And I have a little tiny robot here. I'm going to make run this time, for sure. If you have to elect the most unlucky demo guy today, I think I'm in a good place here. Okay. So the little robot I have here is running Mic Framework on an Arduino. It has a Zigbee connector. I have a little Zigbee adapter here. I'm going to hook it up to the device, to my machine. I'm going to set up a specific port. Obviously, I should have done that before. There you go. And I'm going to tell you what's going on here. That's COM4. No. Boom. And then I'm going to configure something called receive. Okay. So what's going on here is I have the Mic Framework device Zigbee enabled. I have somewhere for it to play. And what I'm going to do is put it on the ground down here because it's going to fall from the table for sure. Because the table is not wide enough. Oops. And you guys will get just to play from your phone with the robot. So I'm using Zigbee to control it from my laptop. And the laptop is connected to Azure using Event Hub. This guy is ready to listen. And I'll be able to send commands from a website or from a device to my gateway, which is my PC. And that PC using Zigbee will actually send the commands to that Mic Framework device to make it run. So there's a website that you can go on your cell phone or whatever to. It's called Robot NetMF Cloud App. And actually, you should be able to send the commands from that website to the robot. What's going on is really the website is sending data to an event hub queue. My gateway here, my PC, is listening to that event hub queue, getting the message, sending it to the robot. So that's really about interacting between hardware, the cloud, with a gateway in the middle. And the reason why I'm using that gateway, I could have that microframework thing connected to Wi-Fi and do something on itself. But what I wanted to show is a very smart device that actually cannot go out of the black lines here because it has infrared sensors, has detected, actually has zeroed out on the white. When he sees the black, it just stops. And so basically it has a level of intelligence down there, running microframework, but it receives the main commands from a backend through a gateway in that case. Zigbee being very common in terms of machine-to-machine connectivity. So here you have a real nice scenario. I could have like dozens of these robots. I could eventually have them sending temperature, whatever data back to up here. I could have a camera, like the one I couldn't make work, connected on that and showing me real-time video on my website. You could eventually build an application that talks to Azure that sends data to the robot itself. So that basically concludes the series of demos, mostly not successful, but some successful, hopefully finishing with that one. You can continue playing with that. If you have questions, I'm happy to answer them, both in terms of what's going on Azure, on the devices, at Microsoft, and so forth. Thanks for your time and your patience on this one. And well, I hope you will get a try at both the devices side of things and the cloud side of things at Microsoft. Thank you, guys. Okay. Questions? Yes? Say that again, sorry? Oh, is the Intel Edison going to be supported? That's work in progress. That's a lot of work in progress. So we definitely want to make that happen. We are actually finishing the Intel Galileo Gen 2 support now. So it's going to take some time before we can actually get onto the Edison. But we're already investigating how much work it is and the direction. So I can't tell you a date, but we definitely want to do that. The other thing is that other hardware will be supported. So running tiny windows on other hardware, there's some that are on the list today, like Minoboard, and others that I can't mention yet because that'd be too cool if that works. But basically, other hardware would support Windows on devices. Okay, yes? So it's, as of this beta version, that's the smallest we were able to do. It basically strips out lots of things that is useless in there. There's a lot of, all the UI is out. Networking stacks have been reworked to be smaller. So we've really been working a lot on stripping out things that are useless on this type of device. 600-700 megs is what we're getting today on that. We can go smaller. That one actually has a bunch of things that you might not need. Maybe you don't need to have the full Ethernet stack. Maybe you just need to connect using Zigbee and you don't need Ethernet at all. Maybe you don't need to encrypt, so you can remove all the crypto stacks. Once again, you really want to think about what you can remove out of that. I don't know what the minimum will be. We want to be small. Yes? Oh, it got stuck into the paper. That's good. That's okay. Is it real? It is. It is the only real demo that works today.